1. Hook. Most developers dive into coding without a solid plan. This often leads to wasted time and resources. Want to learn how to design your AWS architecture before writing a single line of code? The result? Unplanned costs, slow performance, and even downtime. Imagine a startup that launched a new app but didn't plan its AWS usage properly. They faced unexpected scaling issues and massive bills. The rush to code led to a fragile architecture that couldn't handle user demand. This example is more common than you think. 3. The simple explanation. Designing AWS architecture first means understanding your application's needs. It's about creating a roadmap. You define how different services will interact. Think of it as drafting a blueprint before building a house. To start, you need to focus on 3 key areas: user requirements, what features do users need? Performance needs, how many users do you expect? Budget constraints, how much can you afford to spend? These factors will guide your architectural decisions. 4. Real-world example. Let's look at a startup, AppX, that launched a social networking platform. They had a great product idea but rushed into building it. Initially, they used a single EC2 instance to host their app. Within weeks, user traffic surged from 100 to 10,000 daily active users. The EC2 instance couldn't handle the load. AppX experienced outages, leading to a loss of 30% of their users in just 1 week. This incident cost them about $50,000 in lost revenue and user acquisition. After this experience, AppX decided to redesign their architecture. They moved to a multi-tier architecture using elastic load balancing, auto-scaling, and Amazon RDS. This shift allowed them to handle up to 100,000 users without downtime. They also reduced costs by 20% through optimized resource allocation. 5. What to do instead. Here's a clear framework to design your AWS architecture. 1. Identify user needs, conduct user surveys. Define key features and prioritize them. 2. Estimate traffic, use tools like Google Analytics to analyze potential traffic. 100 users? 1,000? 10,000? This will inform your scaling needs. 3. Choose your services. For web apps, consider Compute, EC2, Lambda, or Elastic Beanstalk. Storage, S3 for static files, RDS for relational databases. Network, VPC for isolation and security. 4. Design for scalability, use auto-scaling groups to handle traffic spikes. Implement elastic load balancing to distribute traffic. 5. Set up monitoring, use CloudWatch to track performance and costs. Set up alarms for unexpected spikes in usage. 6. Plan for security, use IAM roles and policies to manage access. Enable encryption for sensitive data. 6. Common mistakes. 1. Skipping the planning stage. Fix, always draft an architecture diagram. Use tools like Lucidchart or AWS architecture icons. 2. Overlooking scalability. Fix, implement auto-scaling from the start. Set thresholds based on expected traffic spikes. 3. Ignoring costs. Fix, use the AWS pricing calculator early in the design process. Set budgets to monitor spending. 4. Neglecting security. Fix, incorporate security best practices from day 1. Regularly review IAM policies and enable MFA. 5. Not testing the architecture. Fix, conduct load testing before going live. Use tools like Apache JMeter or AWS's own load testing services. 7. Quick checklist. Here's a quick checklist for designing your AWS architecture. Identify user needs and prioritize features. Estimate traffic and plan for scaling. Select appropriate AWS services. Set up monitoring and alerts. Implement security best practices. 8. Summary plus CTA. Designing your AWS architecture before writing any code can save you time, money, and headaches. Focus on user needs, performance, and budget. Avoid common mistakes by planning thoroughly and testing your architecture. If you found this video helpful, Drop a comment below with your thoughts. Don't forget to subscribe for more practical AWS tips. Bonus practical tip: if you're unsure what to pick, start with the simplest option that ships today. Then measure for 7 days, latency, errors, deploy time, and cost. Only upgrade when metrics force the decision, not fear.